This is section 3.2, and we're looking at real zeros of polynomial functions. So if you're looking at a function and you want to know how many zeros it has, it's based on the degree of the function. For instance, if I have x to the third as my leading coefficient, or my leading term, I can have up to 3 real zeros. Now, I could have anything less than that as well. I could have 2 real zeros, 1 real zero, but it has at most 3 real zeros. And in terms of turning points, and what I mean by a turning point is like going this direction, and all of a sudden I'm going this direction. This is a turning point. This would be in -1 turning points. I have 3, so in this particular function as my degree, so my turning points will be 3 minus 1, or 2 turning points somewhere in the function. So in general, any zero that is in the function is a place where it crosses the x-axis. It is an x-intercept. You can see this. You could say x minus a is a factor, or you could say a is an intercept. So those all four pretty much refer to the exact same thing. So they're used interchangeably. Let's find all the zeros for this question. First of all, we can set it equal to 0 if we first question. And in both of these, you can factor out at least a 2x squared. And what is left is x squared minus 1, which is 0. You can factor this out further because it's a different square. And when you do that, you get -1. And so if you set each of those equal to 0, we know that we have x equals 0, x equals 1, and x equals -1 for our 0, 0. Now, if we go back to this, we have x equals 4. We know that we have at most 4 zeros. In this case, we only have 3. And we know we have 1 minus 1 turning points, or 2 turning points. So, again, 3 turning points, we can have at most 4 zeros. And let's look at what happens. Notice that we have an x squared equals 0. This is repeated. So that means we have 2x equals 0. So that's the second solution to the 0 because it's repeated twice. That x on the graph is what I consider a dot. It says precedent, but really, in my mind, it bounces off the x-axis. If you have only one multiplicity of 1, or odd number of multiplicities, it goes through across this. So if you have even number of multiplicities, it bounces. If you have odd, it goes through. So let's look at what this graph looks like. So let's move to Desmos and check it out. So let's check that out. I'm going to switch over here, and we're going to look at Desmos. And we were looking at the graph y equals -2x to the 4. And I think it was plus 2x squared. Here it is. Okay, so if we look at this graph, we notice that it has these zeros right here. We have one at -1, one at 0, and one at +1. And notice that it bounces here. Remember we said we had 2x equals zeros? it actually bounces at that point. It goes through the other two, which have an odd repetition or multiplicity. Okay, so when we're talking about bouncing, remember it is even going. It's touching the x-axis and returning, and then the other one, odd, is crossing.